This video tutorial is going to go into how to solve linear equations. So far we've just looked at what an equation is, what are its components, and we've also looked into expressions, algebraic expressions, how to multiply them out, but never have we gone into solving for the variables that exist within these equations. So this is going to be the first video where we actually solve for these variables. What does solving linear equations, what does that actually mean? On the top right, you can see here that I've written out, find the values that satisfy the equation. We're trying to find values, which are just numbers, that when they're plugged in to the variables here, they satisfy the equation, which means the equation equals 0 when fully evaluated. So they're the roots of the equation. Each linear equation will have the variable is going to have the power of 1, so it's going to be to the power of 1. That's what makes it linear. If the variable had a higher power, greater than 1, it would be, like for instance, if it was an x squared, it would be a quadratic, it would be a polynomial of higher powers. But firstly, you start with linear equations, so that's what these examples are. You can see that the variables all have a power of 1. Okay, the premise behind solving these equations is knowing what you can do to them. So essentially the main rule is whatever you do on the left hand side of the equals, you have to do on the right hand side. A little example of why that's vital. So if we have just a numeric equation, 5 plus 1 equals 6, for example, and I say, okay, well I want to add 2 to the right hand side. That's fine, but suddenly 5 plus 1 equals 6, then we have a 2, which equals 8. So suddenly we're trying to equate 8 to 6, which obviously makes no sense. So if you said though that instead of just adding 2 to the left hand side, you also added it to the right hand side, suddenly we'll have 8 equals 8, and that is completely okay. 2 is just an example. It could be anything. It could be 10 to the power of 10, or it can be 5 divided by 4. Like, as long as what operation you do on the left you also do at the right, it will not change the outcome of the equation, and that the left will always equal the right. So there's a numeric example of why it works, why it's important. So you just need to keep that same logic with algebraic expressions and algebraic equations such as these two examples. Right, so we can see that we have a 3x on the right hand side and we have a 5x minus 4 on the left. So the goal is to isolate the variables, the expressions with variables on one side of the equation and have all the constants on the other side of the equation, on the other side of the equals. So thinking back to what we did with that numeric example, if we wanted to get rid of the 3x, this is a positive 3x, we would minus 3x from this side. So we would actually take away 3x from this side of the equation, because 3x minus 3x will be 0. But because we applied it to the right hand side, we then also have to apply the same operation to the left hand side, so the equation stays balanced. So that's the important part. Okay, so then doing this, we now have a 5x, we have a minus 3x. So sorting these out first, 5x minus 3x will give us 2x. And now we'll keep that in now for the first part. And 3x minus 3x gave us 0. Okay, so it's looking a little bit better. We have all the variables are now on this side, all the expressions of variables are now on the left hand side, but we still have a constant that we need to move over to the right hand side. So then using the same logic, we have a negative 4 here, so we want to basically make that expression 0 by adding 4 to it. So we're going to add 4 to the left hand side, and because we have to do the exact same on the right, we're going to add 4 to the right hand side. So then we have a 2x, and we'll have a minus 4 that will cancel with a positive 4 to just give us 0, so we don't need to write that down. And then we have a positive 4 on the right hand side. So when you're, sometimes when you're talking to people or teachers, or where you're looking at online videos is very much like you have a -4 here, you bring it over. I'm not too keen of that because you're not bringing anything over. You're not picking up something and moving it. You're applying mathematical operations to each side to keep the equation balanced. This is what you're actually doing. When someone says you have a -4, bring it over and it changes sign, this is what they mean. So you bring the -4 over, turns into a +4. But I think in terms of understanding this is paramount. We want to have an x equals. So if you have a 2x, just to make that an x, so 1x, we'll have to divide this expression by 2. So on the left hand side, we'll have to divide it by 2. We have to do the same on the right, divide by 2. So just this written in a more explicit form then is going to be 2 over 2x equals 4 over 2. These are going to cancel just to leave an x, and 4 divided by 2 is 2. So this is the value that satisfies this equation. So how do we know that we're correct? The nice thing about these linear equations or solving these algebraic equations is that you can actually check your answer if it's correct or not. You input the value you found for variable x into the original equation, and if it satisfies or balances the equation, you know that it's a correct value. So knowing that, we'll just separate this here. We'll write the original equation with the variable we found inputted in for x, which will give us 5 multiplied by x, which we know to be 2. We have a -4. We have an equals 3 by 2, as x is 2. So then this would give us 5 by 2 is 10, -4 is 6, equal 3 by 2 is 6. So each side of the equation is balanced, or if it makes more sense to you personally and you want to, you have a 6 on this side, so if you want to -6 from here, -6 from here, you'll get 0 equals 0. So this again means that the value you found satisfies the equation because we're left with this end result. Example number 2 is a little more complicated in that it has more expressions, but it's the exact same logic. So we'll just work through that and hopefully we get something of the same sort as we see here. First thing to do with example number 2 here is just evaluate the expressions and multiplying these values out. If you're not too sure how to multiply algebraic expressions, I think it was either 1 or 2 videos ago I do a video on how to multiply these expressions out. So going off the assumption that you're okay with that, we have 2 by 3, so that's going to be 6x, 2 by 4 is +8, -4 by x, -4x, -4 by +1 is -4, and that's equal to 8 by 2x, which is 16x, 8 by -1 is -8. Okay, so there's a lot of stuff going on here. The best thing to do in this situation is just tidy up each side as best you can. So either add or take away, depending on the sign, the variables, the expressions with variables, and the same with the constants. So we have a 6x and we have a -4x. Let's clean that up to 2x. We have a +8, we have a -4, so that's going to be +4. And then this is already tidied up with its 16x minus 8. Okay, so doing what we did over here, trying to get the expressions with the variables on one side and the constants on the other. So eradicating the 2x from this side, we would minus 2x. We do the same operation on the right hand side. So then we're left with a 4 equals 16x minus 2x. It's going to be 14x minus 8. We want to get rid of the 8. So we're going to add 8 because this is a negative. So we add 8 here, which is going to give us 8 plus 4, 12 equals 14. x. So then what we're going to do is divide the right hand side by 14, and then we have to divide the left hand side by 14 as well. 14 is what we do on one side, we do to the other. So then this will cross out, which will leave us with x equals 12 over 14. There's a highest common factor there of 2. So the highest common factor of these is 2. So 12 divided by 2 is 6. 2 goes into 14 7 times. So the value that satisfies this equation is 6 over 7. Hope that was useful. From here, it's probably going to be a case of going up the polynomial ladder, so maybe solving quadratic equations and so on. So if you would like to subscribe, I plan on doing them very soon, and there'll be a whole series of algebra starting from the first video all the way through. So this is just the one step that's on the way to a lot more exciting algebra, what I find exciting algebra. So hope you enjoyed it. Thanks.